When wiring a detached garage from a residential service, the rating of the feeder disconnecting means does not have to correspond to 15, 30, or 60 amps. The rating of the feeder disconnecting means can be sized based on the load calculation. The National Electrical Code does not require specific amperage ratings for detached garage feeders. The rating should be sufficient to carry the calculated load, plus any allowance for future expansion or upgrades. You cannot use a panel without a main disconnect as the disconnecting means for a detached garage. The NEC requires a dedicated disconnecting means for detached structures located away from the building from which they are supplied. According to NEC Article 680.12, b. Service for feeder disconnecting means for each structure, other than dwelling units, shall be installed at a readily accessible location nearest the point of entrance of the supply conductors. The recommended setup for wiring a detached garage is as follows. Firstly, install a fused disconnect switch or circuit breaker at the service panel in the home to serve as the feeder disconnecting means. Secondly, size the disconnect switch or circuit breaker according to the load calculation. Thirdly, run a feeder cable from the service panel to the garage. Fourthly, install a subpanel in the garage with a main circuit breaker to serve as the disconnecting means for the garage circuits. Fifthly, install branch circuit breakers or fuses in the subpanel to protect the individual circuits in the garage. It's important to determine the load calculation. Load calculations involve assessing the total electrical demand that the garage will place on the electrical system. This includes lighting, receptacle outlets, any permanently installed equipment like heaters or air conditioners, and any other appliances or tools that may be used in the garage. The load calculation will determine the minimum ampacity required for the feeder conductors and the disconnecting means. The NEC provides guidelines for calculating these loads, and it's crucial to follow these guidelines to ensure a safe and code-compliant installation. The feeder conductors are the wires that run from the main service panel in the house to the subpanel in the detached garage. These conductors must be sized appropriately to handle the calculated load. The NEC provides tables that specify the allowable ampacity of different conductor sizes based on their insulation type and installation method. It's important to select conductors that are large enough to carry the load without overheating, which could pose a fire hazard. The disconnecting means is a switch or circuit breaker that can be used to shut off all power to the detached garage. This is required by the NEC to provide a means of quickly and safely disconnecting the power in case of an emergency or when performing maintenance. The disconnecting means must be readily accessible, meaning it must be located in a place where it can be easily reached in an emergency. In most cases, the disconnecting means is located on the exterior of the garage, near the point where the feeder conductors enter the building. The subpanel is a smaller electrical panel that is installed in a detached garage. It serves as a distribution point for the branch circuits that supply power to the various outlets, lights, and equipment in the garage. The subpanel must have a main circuit breaker that can be used to disconnect all power to the garage circuit. The subpanel also contains branch circuit breakers or fuses that protect each individual circuit from overcurrents. Branch circuits are the individual circuits that supply power to the various outlets, lights, and equipment in the garage. These circuits must be protected by circuit breakers or fuses that are sized appropriately for the load they are expected to carry. The NEC specifies the maximum allowable load for each branch circuit, and it's important to follow these guidelines to prevent overloads, which could pose a fire hazard. Grounding is another important aspect of wiring a detached garage. The grounding system provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. The grounding system must be properly installed and connected to all metal enclosures, equipment, and appliances in the garage. In addition to the requirements for the disconnecting means, feeder conductors, subpanel, branch circuits, and grounding, there are other NEC requirements that apply to wiring a detached garage. These requirements cover things like the type of wiring methods that can be used, the location of outlets and lights, and the protection of wiring from physical damage. It's important to be familiar with all of these requirements before starting any electrical work in a detached garage. It is crucial to consult the local building codes and obtain any necessary permits before starting any electrical work. These codes may have additional requirements that go beyond the NEC, and it's important to comply with all applicable regulations. The NEC is updated every 3 years, so it's important to make sure you are using the latest version of the code. The NEC is a comprehensive document that covers all aspects of electrical installations, and it's a valuable resource for anyone who is involved in electrical work. Wiring a detached garage can be a complex and potentially dangerous task, so it's important to take the necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit you are working on before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. The NEC guidelines for calculating loads include, firstly, lighting load. Calculate the lighting load based on the square footage of the garage. The NEC provides specific values for watts per square foot that should be used for different types of occupancies. Secondly, receptacle outlets. Determine the number and type of receptacle outlets that will be installed in the garage. The NEC requires a minimum number of receptacle outlets for garages, and additional outlets may be needed depending on the intended use of the garage. Thirdly, fixed appliances. Calculate the load for any fixed appliances that will be installed in the garage, such as heaters, air conditioners, or welders. These appliances will typically have a nameplate that indicates their power consumption in watts or amps. Fourthly, motor loads. If the garage will be used to power any motors, such as those found in power tools or compressors, calculate the motor loads according to the NEC guidelines. Motor loads are typically calculated based on the horsepower rating of the motor. After calculating all of the individual loads, the NEC allows for demand factors to be applied to certain loads. Demand factors are percentages that can be used to reduce the total calculated load, based on the assumption that not all of the loads will be operating at the same time. The NEC specifies which loads are eligible for demand factors and the percentage that can be used. After applying any applicable demand factors, the total calculated load is used to determine the minimum ampacity required for the feeder conductors and the disconnecting means. It's important to select conductors and disconnecting means that are rated to carry at least the calculated load. The NEC provides tables that specify the allowable ampacity of different conductor sizes and the ampacity ratings of different types of disconnecting means. The disconnecting means for a detached garage must be readily accessible. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This means that the disconnecting means must be located in a place where it can be easily reached in an emergency without having to move any obstacles or use any special equipment. In most cases, the disconnecting means is located on the exterior of the garage, near the point where the feeder conductors enter the building. The subpanel in a detached garage must be properly grounded. The grounding system provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. The grounding system must be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode must be buried in the ground and connected to the grounding system with a grounding electrode conductor. The grounding system must also be connected to all metal enclosures, equipment, and appliances in the garage. This helps to ensure that any fault current will flow back to the source and trip the circuit breaker or fuse, preventing electrical shock. The branch circuits in a detached garage must be protected by circuit breakers or fuses. Circuit breakers and fuses are overcurrent protection devices that are designed to protect the wiring and equipment from damage caused by overloads or short circuits. Circuit breakers are reusable devices that trip when an overcurrent occurs, while fuses are one-time devices that must be replaced after they blow. The circuit breakers or fuses must be sized appropriately for the load they are expected to carry. The NEC specifies the maximum allowable load for each branch circuit, and it's important to follow these guidelines to prevent overloads, which could pose a fire hazard. The NEC also specifies the type of wiring methods that can be used in a detached garage. The most common wiring methods are non-metallic sheathed cable, also known as Romex, and conduit. Non-metallic sheathed cable is a type of cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. Conduit is a type of tubing that is used to protect wiring from physical damage. The NEC specifies the types of wiring methods that can be used in different locations and under different conditions. It's important to select the appropriate wiring method for the specific application. The NEC also specifies the location of outlets and lights in a detached garage. The NEC requires a minimum number of receptacle outlets for garages, and additional outlets may be needed depending on the intended use of the garage. The NEC also specifies the minimum height for receptacle outlets and the maximum spacing between receptacle outlets. The NEC also specifies the minimum number of lights that are required in the garage and the minimum height for lights. The NEC also requires that all wiring in a detached garage be protected from physical damage. This can be accomplished by using conduit, by running the wiring through walls or ceilings, or by using other protective measures. It's important to protect the wiring from physical damage to prevent damage to the wiring and to reduce the risk of electrical shock. The NEC also contains requirements for the installation of electric vehicle charging equipment in detached garages. If you plan to install an electric vehicle charger in your garage, you will need to comply with these requirements. The NEC specifies the type of wiring methods that can be used for electric vehicle chargers, the size of the conductors that are required, and the type of overcurrent protection that is required. It's important to follow these requirements to ensure that the electric vehicle charger is installed safely and correctly. In addition to the NEC requirements, there may also be local building codes that apply to wiring a detached garage. These codes may have additional requirements that go beyond the NEC, and it's important to comply with all applicable regulations. The local building codes may also require you to obtain a permit before starting any electrical work. It's important to check with your local building department to determine what permits are required. Wiring a detached garage can be a complex and potentially dangerous task, so it's important to take the necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit you are working on before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. Ignoring the NEC can lead to dangerous situations such as electrical fires. Electrical fires can occur when wiring is not properly installed or when overcurrent protection devices are not sized correctly. Electrical fires can cause serious damage to property and can even result in injury or death. Electrical shock is another potential hazard that can occur when wiring is not properly installed or when grounding systems are not properly connected. Electrical shock can cause serious injury or death. Fines and penalties can be imposed for violating the NEC or local building codes. These fines and penalties can be significant, and they can be a major financial burden. Insurance coverage may be denied if electrical work is not performed in accordance with the NEC and local building codes. This means that you may not be able to recover any losses if your property is damaged by an electrical fire or other electrical accident. Selling your home may be difficult if the electrical system is not up to code. Buyers may be hesitant to purchase a home with an electrical system that is not compliant with the NEC and local building codes. In summary, the disconnecting means can be sized according to load calculation. However, you cannot use a panel without a main disconnect as the disconnecting means for a detached garage. It is a good idea to follow the steps outlined earlier in the answer for the recommended setup.